Hello everyone. I'm Andy from ThinkMo. I'm currently teaching CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is: how can IPv6 address resolution be implemented without ARP? Next, we will focus on three aspects. IPv6 address resolution mainly involves NDP protocol. We call it Neighbor Discover Protocol. It explains the first problem. What is the NDP? So what does the NDP protocol do? Let's look at it briefly. It can realize router discovery. Discover the router on the link. And get the router announcement information. Of course, announcement contains a lot of information. Let's say a PC is connected to a router. In general, the router advertises it. It can serve as a gateway for this PC. When we visit the internet, it's communication across network segments. We need to find the gateway. So in IPv4, there is usually a gateway address. So the discovery function of the router is very important. The second is stateless automatic configuration. It's called SLAAC. It is a prefix that is advertised through the router. It's the router. Give me the segment prefix information. And then automated based on that network segment. Procedure for configuring an IPv6 address. So what does it show? Is that these computers that I have? Just plug in the cable. You can access the internet without configuration. It is possible to have no one who understands network technology. Implement plug and play function. The third one is DAD. It's called address duplication detection. Similar to free ARP in IPv4. It detects address conflicts. Let's say two devices. An IPv6 address is configured. Procedure. Once configured, these two addresses are not available yet. We need to test each other. Check whether you also configured the address I assigned. If there are other devices on the other link, plug in. It depends on the address it's assigned to. Whether to take one of the two devices. IPv6 address of the device interface. To prevent address conflicts, get tested first. Then determine if the address is available. And then there's address resolution. And that's what we're going to focus on today. Address resolution does not depend on ARP in IPv6 because it has no concept of broadcasting. How do you resolve an address without relying on ARP? We'll come back to that in a second. The next step is neighbor status tracking. It means before you send the data, you have to detect it in advance. See if your phone's off here. Let's say this one doesn't work. Or the circuit is broken. The first thing to see is whether it can be used normally. The next step is prefix readdressing. For example, to implement the change of IPv6 address, that's in the process of replacement. Our business can't be interrupted. So we're going to implement prefix readdressing. Ensure that services are not interrupted. Change the IPv6 address. Another is route redirection. It also exists in IPv4. It's telling the other devices before reaching the target network. If you have a better next hop, just use it. This redirection feature is just not used much. Basically, all major manufacturers of equipment. The redirection function is turned off by default. We can also turn it on. This is what we call the NDP protocol. The functionality in it is based on ICMPv6. In IPv6, we call it ICMPv6. In IPv4, we call it ICMP. ICMPv6, it is no longer like IPv4. depends on ARP, the Address Resolution Protocol. Keep these functions in your own hands. Because in terms of ICMP, it is IPv6. It's the equivalent of ICMP in IPv4. It belongs to IP. It's IPv4. And then you can do it yourself. Some functions of address resolution. For example, route discovery, stateless automatic configuration, and so on. Now let's talk about IPv6. How do I complete address resolution? IPv6 address resolution. Two types of packets are involved. It is based on ICMP-v6. I just mentioned that. So in ICMP-v6, address resolution is involved. The corresponding two types of packets. One type is NS packets. It is called a neighbor request packet. The other is NA packets. It's called a neighbor notice. So what about the neighbor request message? I am in an NS packet. The data is encapsulated. So how exactly is it encapsulated? First, I use the IPv6 address of the other party. Global IPv6 unicast address to be precise. Let's say I have PC1 over here. The address is 2001.164. PC2 is 2002.164. And now it's connected by a wire. PC1 then sends a packet to PC2. Before sending the packet, you want to do address resolution. First, the data is encapsulated for PC1. You need to be careful in this process. Use your own IPv6 address as the original address. So the target address. This is the IPv6 address of PC2. The multicast address of corresponding requesting node. This is what we call a three-layer package. Layer 2 encapsulation. MAC address indicates the MAC address of the interface. The target MAC is the multicast IPv6 address of the requesting node. Mapping the corresponding multicast MAC address. Convert to a multicast MAC to the target MAC address. In this way, the NS packet is encapsulated. And then you send it to PC2. PC2 received the message. At this time, it needs to reply to an NA packet. The original address of the NA packet is IPv6 address of the user. This reply is a unicast reply. PC1 is sending NS packets. It is the neighbor request packet. I've got my original address and the original IPv6 address and its own original MAC. So when it gets there, the returned NA packet, it is the packet requested by the neighbor. The original address is its own IPv6 address, and the destination address is my destination IPv6 address. And then the original MAC address is the target of its own interface. The MAC address is no longer a multicast MAC. It is the MAC address of PC1. It is unicast behavior. Thus, two-way address resolution is completed. And then the next thing. We're ready to communicate. So let's take a look at this picture. First, the original address is your own. 2001.164. The destination address is from PC2's 2001.264. Multicast address of the requested node. The requested node then multicast address. Then convert it to a layer 2 address. It's just 4 threes. This is the IPv6 multicast MAC prefix. Then take the next 32 bits. Map to a multicast MAC. Then the packet is encapsulated. Send to peer. And then PC2 gets it. In this case, the source address is itself. The original address was my own. The destination address is the other party's. And then the source MAC is itself. The source address is itself. The destination MAC address belongs to peer. This is unicast behavior. This completes address resolution. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.